Welcome back, everybody. So we are looking at example 1 on page 109 of the workbook. And this is the first example to illustrate the second fundamental theorem of calculus, the theorem that you see up here, right above this example that we're about to do. And just to re-emphasize what the theorem is saying, basically the key point is sitting here on the last line. It says that if we take a derivative of a function that's defined as an integral in this way, the derivative and the integral cancel, and we essentially get the function back that we started with. Okay, so take example 1 here. They're defining a function capital F of x to be this integral and asking us to calculate its derivative. Okay, so the short way to do this would be to notice that the derivative of capital F of x is literally just asking us to take the derivative of the integral from 1 to x of t squared dt. And so if we believe the fundamental theorem of calculus up here, it tells us that the derivative and the integral should cancel, and we should really end up with that function inside with x's substituted in for t. Okay, so this has to be our answer by the second fundamental theorem of calculus. Okay, I'd like to do one more step though here and really confirm, if we can, in the case of this example, that our answer is reasonable. Okay, so to check this, we can do this same calculation directly. So we'll check this by direct calculation. Okay, so the same derivative that we just took, we could do by actually evaluating this integral that I'm underlining before we take the derivative. All right, so how do we do a definite integral like that? Well, we need an antiderivative, so we'd start by finding an antiderivative for t squared. That's going to be t cubed over 3. Then we would need to substitute in our two limits. Okay, and notice that what's a little unusual is that our upper limit is a variable, x. That's okay, though. We'll treat it the same way we would a number. So substitute in x for our t. We're going to get x cubed over 3. Okay, minus, substitute in our lower limit, that's 1 cubed over 3. Okay, and to finish this, we just need to now take the derivative of those two things. So starting with x cubed over 3, what would its derivative be? Well, 1/3 is a constant, and the derivative of x cubed by the power rule would just be 3x squared. And then what do you get if you take the derivative of a constant like 1 cubed over 3? It goes to 0. Okay, so notice what happens here. The 3's cancel, and we get x squared, and that's exactly the same answer that we got up here. Okay, so just kind of a little confirmation of this theorem for one example.